Hello, everyone, and welcome to the Q&A session with Dr. Uddin. First of all, on the behalf of our committee, I would like to thank everyone for your attendance here with us, and we hope you're enjoying our Congress so far. Secondly, and not less important, I would like to welcome Dr. Uddin and say what a pleasure it is to be here with you today. I would also like to thank you again for accepting our invitation in this year's Congress. Um, I'm very excited to listen to you answer all the questions that we have on this very important topic for everyone. Before we get started with the questions, is there anything you'd like to say, Dr. Udin?
Thank you very much, the organizer, and it is really a great pleasure for me to giving a talk here. And my English is little bit fast, so I try to give answer little bit slow. It's okay. Thank you very much. I just appreciate it, and I'm happy to talk to everybody ready for answer.
It is our pleasure to have you with us today. Okay, let's get started with the questions. The first question is from Andre. Thank you so much for your question. He says, what criteria does Dr. Udin propose for the ideal detection method for heavy metal contamination? And why does he believe it should be accessible to individuals with varying levels of expertise? Don't you believe that this action can generate wrong results and create false alarm among the population?
No, not like that, because in this we try to target some particular heavy metal like copper and mercury, and we try to do a very small consultation. We check it with our paper strip and others. So, but and next in research work, we are going to convert this data qualitatively, quantity in the digital forms. So we are converting what our information getting in exact quantity. So how much quantity is getting? So I am not saying that we almost reached the 100% our prototype, but initially what we try to cover that information we get it, at least we can get the information that some contamination is there. I can say that it's 100% accuracy, that may be a fluctual because we are taking as a naked eyes, but we try to convert this in digital forms. We are try to contact some physics research collaborator, and we are making a prototype for this. So I think so in the future work we can go directly and on-site interaction. Yeah, thank you very much, I think.
Yeah, thank you so much, Dr. Udine, for answering our first question. We have many questions here, of course, thanking you and congratulating you for your lecture. The second question is from Alessandra. Thank you, Alessandra. She says, good afternoon. The lecture was very interesting. In a practical and large-scale manner, how would the detection of these contaminations work in different environments?
Different environment actually, as I am telling to you that we tried this prototype in lab level, and as well as we check the samples from different area. Like we take the our nearby contamination where present something. So we check different areas, and we try to find out the information that this is can do it. So in my opinion, till my study, so different environment in the sense like different contaminated area where the water sample has there a different concentration. So it should be work well. Whatever sample we get, we are working very well, and we got very promising results. But definitely we are using our paper strip, and this paper strip don't need any molecular environment. We can go any water sample, like we can bring this to Europe also, US also, or maybe because we need in a small pocket, no need to carry all this thing. So there is no effect of environment, which environment you are working. The samples which we are using, which should be a contaminated, I think so we can get a much information from this. Yeah, I hope so I answer this.
Thank you, Dr. Udine. Yeah, I think tropical countries like Brazil are similar to environments that are from India would be a good place to start. Um, Thank you for answering the second question. The third question is from Nayada. Thank you, Nayada. She says, thank you, Dr. Uddin, for this great lecture. Are there other potential applications of this heavy metal detection technology beyond water testing? How could it be adapted for other environmental monitoring purposes? So a similar question,
Yeah,
Uddin.
next actually our target to first we try this for heavy metal in the water, but we mostly want to take some food sample also, like how much, like if there is a in a land area where the agriculture field are there, the water conditions are there. So next target, like heavy metal contamination we check from different nanoparticle in food sample also, but our idea is to that on-site detection, like we just want to make a paper strip. So we trying to we our lab is working on the to generate some type of paper strip which can detect into some food sample also, like if there is a chances to there or other environment, but still the research is going on. But I think so, because cadmium sulfide or other nanoparticle there is have a heavy metal detection properties, and there is a report also. So in my opinion, like we can convert into a paper strip or some type of digital device, it may be a possible. Yeah, thank you very much.
Thank you, Dr. Udine. Many questions here, many people congratulating your interesting work. Okay, next question is from Alessandra again. She says, wonderful lecture, Dr. Udine. Have you tested the shelf life storage time of CDS impregnated strips in relations of its heavy metal reactivity?
So timing is nothing is there. Like we when implicated this cadmium sulfide nanoparticle or quantum dots on the paper strip, so you can keep for a long time. There is no chances to contamination or shelf life. So it is like you can use after 1 month, 6 months, 1 year, 2 years, because this is the quantum dot and on paper strip. So there is no chances of contamination. So for, as you say, shelf life, there is no meaning of shelf life. We can use anytime. It is just like a small devices. You can say a small device which can detect it. So you keep in your place where you, and whenever you want to check detect, just check your water sample and dip it. If there is a color changes, how much color is changes, you immediately can find out. So there is no worry about the shelf life. It work for a long. From last 1 year, I am using for my first sample, or still they are giving a very nice results. Thank you.
Great, thank you. That is one less problem we have to worry about. Thank you, Dr. Udine. Okay, next question is from Julio. Thank you, Julio, for your question. Um, he says, wonderful lecture, Dr. Udine. Um, Thank you for your explanation. Which nanobiosensors are currently used to detect and monitor heavy metals? Which ones have the best value for money? And what could be done in terms of the RPSL method?
There is so many nano biosensor. It is not like that which biosensor nowadays using. The guys are using for glucose detection. Diabetes are nowadays too much, which is using a nano based sensor, which and there is also in market that is using for alcohol detections. So there is too much in market. What exactly nowadays is you are using it? Maybe things. My most concerned about the heavy metal detections. So this is nanoparticle are using for heavy metal detection before that also, but they are using in the liquid form. We are trying to make as cheap as possible. Same technique we just convert into as cheap as possible, which is just in $1 you can more than 500 strips, and it is one of the cheapest way. Like any farmer, any poor guy which are not educated, he want to check its water sample from his land, then he can check it. So idea is to that what our new biosensors, I don't have any idea okay, what exactly now which one is a new one is using, but there is a lot of in market is there. Yeah, thank you.
Thank you, Dr. Udine. I was reading the article about this, and that really intrigued me, the simplicity of the research and how easily it can be done. So thank you. A lot of other people thanking you for your work and your lecture. One last question from Felipe. He says, Good afternoon. In the synthesis of nanosensor and detection of heavy metals, agitation and heating are necessary. How can the same reaction between the sensor and the analyte be achieved on the strip?
See, well, we synthesize the CDS quantum dots at 60 to 80 degrees Celsius. Like my reaction temperature was 80 degrees Celsius. So first we synthesize our CDS quantum dot on 80 degrees Celsius. When CDS quantum dots are successfully we found, we check the its sensor with the heavy metals in the liquid form first to confirm that it is working very well or not working well. Then after that, we coated this quantum dot, this CDS quantum dot, with our paper strip. So in for coating the paper strip, we don't need any type of heating system. We just simply dipped it for a long time because we know the paper strip can absorb it. Just for dry it for, that does remove the water. We give little bit heating to it just to increase the temperature like 40 to 50 degrees for a long time, like 1 2 days. So it is a very nice paper strip. We got it. So we didn't use any heating for this. Just for synthesis CDS quantum that we use something. Thank you very much.
Okay, thank you, Dr. Udine. That is all for the questions that we have for now. So I, once again, on the behalf of our committee, I would like to thank you so much for your presence here live with us, as well as for your wonderful lecture. And that is all. Thank you so much, Dr. Udine.
Thank you very much also for the organization. And my email ID is everything's or uh, my in on my presentation. So if anybody interested, directly write me or my LinkedIn profile or WhatsApp. I'm very happy and I'm very much thankful to organizer also. So arrange a wonderful, even my from India. So many my universities are looking on the YouTube for this. So thank you very much.
That is wonderful news. Thank you, Dr. Udine. We will sure to keep your information available and keep in touch for future partnerships. Thank you. As for
Thank
everyone
you.
else, I would like for you to ask everyone to join us on our entertainment rooms, which can be found on Kumo Space. We have nano games. We also have an AI room, and I hope you guys stay tuned for our next lectures starting at 4 o'clock with Dr. Goldbeck. See you soon, guys.
Bye.